Assalamualaikum and good morning, students. Okay, so we proceed to chapter 3. Chapter 3 is about periodic table. So we have only two subtopics in this chapter. So the first one, classification of element, and the second one is periodicity. So we will cover for the first subtopic first in this lesson. Okay, the learning outcome are describe period. What is period, group, and also block that represent in the periodic table. Second one, from the periodic table, we can deduce or identify the position of element from its electronic configuration. So this electronic configuration we have right in the previous chapter, in chapter 2. Subtopic 2.3, and describe the variation in atomic radii. What happened to the size of atom, okay, when across a period and down a group. And last one, define the term isoelectronic. So this is the introduction for periodic table. Okay, elements in periodic table are arranged in increasing proton number or increasing atomic number from left to right. So elements in periodic table are divided into three main types. Okay, the first one, metal. Okay, metal, the element which are in yellow color, metalloid purple, and non-metal green. So metal refer to all elements on your left hand side. So left hand side except hydrogen. So we call all of these elements metal or metallic, which has character of metal. Then separate by, on your right hand side we have non-metallic. So non-metallic separate by step line, okay, ataupun kita nampak macam tangga, okay, staircase. Okay, so all of these elements on your right hand side are called non-metal, including, okay, so don't forget, including hydrogen. And between this metal and non-metal we have semi-metal, or we can also call metalloid. So this metalloid will have character of metals and also non-metals. For the first exercise, classify element that are metal, metalloid, or non-metal. So remember, on your left hand side, okay, left hand side, all elements are metal. Right hand side, all elements are non-metal. So left hand side refer to W, V, Y, and R. So remember, this one is hydrogen. So element that are metal, W, V, Y, and R. For non-metal, ST, S, T, U, and X. So element Z is metalloid. So we have these terms that are important in explaining element in periodic table. So we have period, block, and also group. So we know that all elements in periodic table are arranged in order of increasing proton number. So for vertical column meaning daripada atas ke bawah, we call as group. And horizontal row represent daripada kiri ke kanan, we call as period. Block we refer to a group of element, okay, beberapa group, okay, kita classify dia sebagai block. Okay, this block of element based on the same electronic configuration. So we will go in detail after this. So period refer to horizontal row from left to right. So in periodic table we have 7 period. So each row arranged in order of increasing proton number, and each row represent the number of energy level. So for example, we have this one 1, 2, 3, 4, 5, 6, 7. So 1 represent n equals to 1 or principal quantum number n1. This one n2 second level of energy or principal quantum number n equals to 2. So that means each row represent number of energy level in an atom. Okay, total number of period is 7 period. So we have period 1 for hydrogen and also helium. So number of period actually equal to the number of principal quantum number. For example, we have sodium. From the electronic configuration of sodium, 1s2, 2s2, 2p6, 3s1. Okay, we have the largest principal quantum number is 3. N equals to 3. Okay, so from n equals to 3, we can identify that this element, sodium, is in period 3. Same goes for chlorine. The largest principal quantum number refer to n equals to 3. So chlorine also in period 3. So we can conclude that number of period equal to the number of the highest principal quantum number of the element. So from this exercise, can we identify which period of this element belong? So according to the electronic configuration, for element A, we have the largest principal quantum number 4. So element A is in period 4. So B, the largest principal quantum number n equals to 2. So period 2. So this one largest principal quantum number 4, period 4. Largest principal quantum number for element D n equals to 3. So period 3. For element E, largest principal quantum number 4, period 4. So same goes for F, largest principal quantum number n equals to 4. So remember, period equal to the largest or highest principal quantum number. Then we proceed to block. So based on electronic configuration, okay, we can determine block of the element. So we have 4 main block: S block, P, D, and F. Actually, this name of the block is equal to the name of the orbital in an atom. So kita ada orbital S, orbital P, orbital D and orbital F. Okay, sama. So untuk to determine this block for element, kita akan tengok sama juga the largest ataupun highest principal quantum number of the element. Okay, S block refer to element that are in this one, group 1 and group 2, including helium. P block on your right hand side, so starting from group 13 until group 18. D block for transition elements starting with group 3 until group 12. And F block is refer to the sub element for group 3, period 6 and also group 3, period 7. So this is the explanation for S block refer to element in group 1 and group 2. So the highest principal quantum number including S orbital only. So we have the general electronic configuration for valence electron starting from ns1 to ns2. For example, we have sodium. So from electronic configuration 1s2, 2s2, 2p6, 3s1. So 3s1, okay, actually kita dah determine this is in period 3. Okay, because we have the largest principal quantum number n equals to 3. Okay, then from the largest principal quantum number 3s1, okay, we can also determine this element is in block S. So same goes to calcium. So 4s2 meaning block S period 4. So that's why we say that the general electronic configuration for valence electron is starting from ns1 until ns2. So actually ns1 refer to, okay, 1 represent group number. So meaning group 1. So kalau ns2 meaning group 2. So remember untuk block S, they refer to element in group 1 and group 2. So for P block element, so P block tadi pada right hand side. So starting from group 13 until group 18. So we have general electronic configuration for valence electron starting from ns2 and p1 until ns2 and p6. So P refer to block P. Okay, why ns2 and p1? So actually this one ialah refer to group for that element. 2 plus 1, okay, 2 from ns2, 1 from np1. Okay, so plus 10. So total ialah 13. So meaning dia ialah group 13. Okay, why we need to plus 10? Because this element are in right hand side. Right hand side meaning dia dah lebih daripada 12. So 12 tu sampai transition element. Okay, tapi dia still ada 3 valence electron, tapi dia in block P. So we need to add another 10. So same goes untuk this one. So 2 from S orbital plus 6. So total is 8. So plus 10. So we have 18. So that's why in group 18. Okay, for example, we are given electronic configuration for aluminium. So from this electronic configuration, okay, we deduce that the highest principal quantum number n equals to 3. So n equals to 3 meaning this element is in period 3. So we have 3s2, 3p1. So the largest orbital refer to p. So this is in p block. Okay, from this highest ataupun valence electronic configuration, we can also determine group, number of group. So 2 from s orbital plus 1 from p orbital plus 10 because in p block. So meaning this element is in group 30. Okay, another example, we have 5s2, 5p4. So this element is in period 5, block P, group 4 plus 2 plus 10, group 16. So this element, 4 elements that are in D block. So refer to all element in transition. Element refer to element that are in group 3 until group 12. Okay, according to the valence electronic configuration. So we have n-1 d1 until ns2. So remember for d orbital, okay, we have the lowest d orbital ataupun d orbital yang exist ialah bila n equals to 3. So here, if we have 3 d1, so n principal quantum for s orbital mesti larger 1 compared to d orbital. So meaning kalau 4s2 dia ialah 3d1. So kalau sini 4d1, so sini perlu 5s2, mesti lebih 1. Okay, reasonnya sebab kita akan isi elektron di S dulu, kemudian baru pergi D. Okay, ini dalam Ahbab principle. Electron are filled for orbital with lower energy first before the higher orbital, higher energy orbital. So macam ni lah. After kita isi elektron di 3p6, next kita isi kepada 4s2. Baru pergi kepada 3d3. So that's why principal quantum number for s orbital dia lebih 1 compare dengan d orbital. So according to this highest principal quantum number, we can see that vanadium, okay, is in group 5. Okay, D block refer to this one. Okay, block D. Period still refer to the highest or largest principal quantum number, period 4. So for electronic configuration, some books will use this form of writing. So actually sama. Actually this one ialah short form untuk 1s2, 2s2, 2p6, 3s2, 3p6. Dia sama dengan electronic configuration of argon. Okay, kita just tulis dia punya short form AR in bracket. So yang ni hanya boleh ditulis untuk elemen group 18. Okay, dia apa? Short form untuk sinilah sampai 18 electron. Okay, last one, F block refer to all elements that are sub to period 6 and also period 7. So refer to lactanide and actinide element which having the electronic configuration, okay, largest electronic configuration refer to F block for F and also 5F. Okay, and last one we have a vertical column. Vertical column called group. So vertical refer daripada atas ke bawah. So kita ada 18 group. So this group equivalent to the number of electron in their valence shell ataupun the largest principal quantum number. So kalau group 1 refer to valence electron dia ataupun largest principal quantum number ada 1 electron. So this one group 2, 3, 4, 5, 6 until 12. Okay, this one 13 until 18. So element that are in same group will have same number of electronic valence electron and also similar chemical properties. For example, all elements in group 1 from sodium until cesium, we have only one valence electron, but they are different in number of period. Okay, for example, here we have hydrogen 1s1. So from number of electron, lithium 1s2 2s1, sodium 1s2 2s2 2p6 3s1. So if you can see here, okay, we have the largest principal quantum number for hydrogen n equals to 1, meaning hydrogen is in period 1. So for lithium, the largest principal quantum number n equals to 2, so lithium period 2, sodium period 3. So if we can see that all electron equals to 1 for element in group 1. So the difference are in period number. So period 1, period 2, period 3 and so on. Tapi number of valence electron dia sama. Okay, so this is the general idea to determine group for element for S block element. Okay, number of group sama dengan number of valence electron. But for P block, we need to add 10. Okay, D block sama dengan S block. Kita calculate, kita identify which one is the highest principal quantum number dan kita tengok ada berapa valence electron. Jadi itulah dia punya number of group. Okay, let's go to exercise 3. Determine block and group for this element. So we have element A with proton number 20. Okay, from proton number 20, we can write the electronic configuration according to above, Hans, and also Hans and above. So the highest principal quantum number refer to the highest principal quantum number ataupun valence electron. Okay, we have n equals to 4. So this element is in period 4. Okay, block refer kepada sini juga. So block S. Okay, and group 4s2. So 4s2 meaning kita ada 2 valence electron. So group 2. So this one refer to the largest principal quantum number 2. So period 2. So period 2 ending dengan 2p6. So dia adalah block P. So remember untuk determine group for period for block P kita perlu tambah 10. So 2 plus 6 plus 10. So group 18. So for C, okay, untuk determine period kita akan tengok the largest principal quantum number. So period 4. Okay, then ada D, 3D5. So this one ending di D. Jadi dia ialah blok D. So untuk elemen dalam blok D, kita tak perlu tambah 10, just tambah 2 from 4s2 dengan 5. Jadi dia ialah group 7. Elemen D, largest principal quantum number 3, so period 3, so block refer to block S. So 3s1 refer to 1 valence electron, so group 1. So this one same goes untuk C. Macam C tadi, so period 4. Okay, then block ending di 3D, jadi block D. Group 10, 8 plus 2. Okay, last one, 4s2, 4p6. So period 4, because largest principal quantum number 4, so dia ending di 4p6, so dia adalah block P. So untuk determine group for block P perlu tambah 10. So 6 plus 2 plus 10, 18. Okay, these are the explanation for that exercise. Okay, from exercise 4, okay, write the electronic configuration for the given element. So we have element PQRST. So we are given period, group and block. So actually we can write the valence electronic configuration, tapi untuk tulis full electronic configuration, kita akan start with 1s. Okay, kita determine dulu apa dia punya valence electronic configuration. So period 3 meaning ending with 3. So group 18 block P, so meaning kita ada 3s dengan 3p. So group 18 meaning we have 8 valence electron. So 8 valence electron come from 2 from 3s, 6 from 3p. So 3s2, 3p6. So to write the full electronic configuration for element P, kita just reverse. So mulakan daripada 1s2, 2s2, 2p6, okay, then continue 3s2, 3p6. So this is the electronic configuration for element P. Then for element Q, so block P period 4. So kalau period 4 meaning kita ada 4 S and 4P. So 4P because dia adalah block P, so mesti ending dengan P. So group 17 meaning ada 7 valence electron. 7 valence electron come from 2 daripada 4S, 5 daripada 4P. So kita akan tulis before 4S tu 4P5 ada apa. So kalau kamu tak ingat, boleh buat macam 1S, 2S, 2P macam tu. 3S, 3P, 3D, 4S, 4P. So 1S, 2S, 1S2, 2S2. After 2S, 2P, 3S, 2P6, 3S2. After 3S2, 3P6, 4S2, 3P6, then 4S2. After 4S2, 3D. So sini 3D10, 4S2. Okay, so these are the electronic configuration for element Q. For element R, okay, we have S block, meaning endingnya ialah S and period 4. So 4S. Okay, kenapa 4S? Because period 4 S block. Jadi 4S dia punya valence. Jadi group 2 meaning ada 2 valence electron. 4S2. So electronic configuration starting with 1S, 2, 2S2, 2P6, 3S2, after 3S, 3P, 3P6, after 3P6, 4S. So This is the electronic configuration for R. Okay, then for element S, okay, D block, kita ada period 4, group 5. So for S2, 3, D 3. Okay, block D refer sini. Okay, period 4 refer kepada principal quantum number, highest principal quantum number for S2. Kemudian group 5 refer to 2 electron from 4s, 3 electron from 3d. So kita akan tulis full electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6. Okay, after 3p6, 4s2, after 4s2, 3d3. Okay, continue je. 4s2, 3d3. So ini electronic configuration for element S. Okay, and last one for element T. Okay, kita ada D block juga. So period 4. Okay, group 12. So 4 dengan 3 because ada D. So, D. Okay, untuk jadikan 12, 10 daripada D, 2 daripada 4S. Jadi 2 plus 10 jadi 12. So before 4S2, 3D10, kita ada 3P6, 3S2, 2P6, 2S2 and 1S2. 1S2, 2S2, 2P6, 3S2, 3P6. After 3P, 4S, then 3D. So this is the electronic configuration for element T. Okay, this is the answer. Okay, so that's all for 3.1. To determine group, period and also block of element based on periodic table. So for 3.2, we will continue next week. Thank you, class.